Welcome to Building Conversations, a construction podcast powered by the STO Building Group. On today's episode, Justin Goodman, Director of Business Development at Structure Tone Southwest, has a conversation about the complexities of building blast-resistant structures with subject matter experts Aaron Westover, Vice President of the Industrial Division at Rigid Building Group, Chris Talley, Regional Vice President of Structure Tone Southwest, and Rudy Tejeda, Vice President of Industrial Work for Structure Tone Southwest.
Good morning. We are here with the STO Building Group podcast. Today we'll be talking about the blast buildings and the blast business and what all that means. My name is Justin Goodman. I'm the Director of Business Development here in Houston, Texas. With me today I have Aaron Westover with Rigid Metal Buildings, Chris Talley, the Regional Vice President for Structure Tone Southwest, and Rudy Tejeda, VP of Industrial for Structure Tone Southwest. Let's go ahead and get started, guys. So before we jump into it, I'd like each of you to take 2 to 3 minutes to introduce yourselves, tell me what you do and kind of your role in this blast world. We'll start with Aaron.
So I've been in the pre-engineered metal building industry for 21 years now, and specifically over the last 6 or 7 years working for Rigid Global Buildings, developing their industrial division. Specific partnerships have been put in play with Baker Risk Engineering with a heavy focus on blast-resistant design and fabrication. So a little bit about myself. I'm currently acting as the Vice President of Rigid's Industrial Division, again, with the focus in the petrochemical, oil and gas industries.
Awesome. Mr. Talley.
Well, I'm Chris Talley. I'm the Regional Vice President for Structure Tone Southwest in Houston. So we're really responsible for projects along the Gulf Coast. We execute anywhere from Lake Charles, Louisiana, all the way down to Corpus Christi. Our major clients, as you can imagine, are the refiners and chemical companies associated all along the Texas Gulf Coast and the Houston Ship Channel. We really brought this kind of expertise of this kind of building to Structure Tone maybe 4 or 5 years ago with a concerted plan to chase this kind of work because of where we are geographically and the kind of clients that we have in Houston. So happy to be here and answer these questions.
Yeah. Fun little anecdote before we jump to Rudy is Chris actually hired me 15 years ago out of the Harvard of the South, aka Texas A&M University, and we both worked at Jacobs with Rudy, who will introduce himself next for, almost the better part of a decade, I think. So with that, Rudy, why don't you give a little background to yourself?
Okay, I have about, 24 years experience with blast. My background is actually an architect, and I've kind of worked my way into this type of field, but I am the Industrial VP for Structure Tone. So hopefully we'll be answering all your questions and enlighten you guys.
Well, that's great. Well, so with that, Rudy, I'm going to stay on you right now. As kind of our resident blast experts, can you give our audience kind of what I would say a blast 101? What is a blast building? Why do we have them? Where are they? And Chris and Aaron, you guys feel free to chime in as well to kind of help build the picture before we go into specific questions.
So blast as a high level is basically of course we've seen all these industrial incidents that have happened, and making a blast building, we're not making it blast proof, we're making it blast resistant. There's different types of blast buildings. There's some that during a blast event, they will not feel anything interior wise except a vibration. So that building needs to be ductile. Then there's also buildings that are a little more, I would say, you would receive more damage on them, is to mitigate some of the fatalities. But the idea is to try to keep or limit or mitigate any fatalities for the building occupants.
And so these are buildings inside of a plant, like admin buildings or a laboratory. Yes. What kind of buildings are we talking about?
So the typical buildings you see in the industrial world are maintenance buildings where you have the people who go do the shops, welding, drilling, pressing, anything like that. Maintenance for the plant, so that's your maintenance buildings. You have central stores, which is where they keep all the product, equipment, consumables. You also have admin buildings there for the engineers of inside the plant, admins, any type of support they need. You also have control buildings, which is a critical building. The control building is basically the building that is the brain of the unit or process of the chemical or oil they are refining.
Chris, Aaron, anything you want to add to the lay of the land there?
Yeah, I think Rudy pretty much hit the nail on the head. You know, we service all types of buildings, inside the fence, maybe a little outside the fence, but admin buildings, warehouses, labs, firewater pump buildings, and it all kind of revolves around where the structure is going to be sited within the facility as to what type of blast damage is acceptable or isn't acceptable to the client.
So really the work that we're doing kind of rolls right in line with Structure Tone or STO Building Group's Safety 360, right? Mm-hmm. These are people potentially in harm's way that we're building a product that's going to keep them safe and allow them to go home every day.
That's right.
Yep.
That's awesome.
That's exactly right, Justin. If I might add on, these are buildings that are going to save lives, and that's exactly why we all kind of got involved with these. Right. Several years ago, after a large explosion in Texas City, if you remember, it really piqued our interest and everyone else's interest in this whole industry, and it really elevated our game in what we can deliver. And I'll just add that these are very technical and complex buildings. Even though they may look simple, these are very technical buildings based on a complex blast profile that some of our consultants like Baker Risk would provide.
And just to add to that, the interesting thing, this isn't something you pick up and go, hey, I want to go to college to design blast buildings. It's really something you learn on the job, and how you treat blast with all the different type of building systems, envelope, HVAC, electrical, plumbing, the skin. I mean, everything is affecting that building. So it's interesting how that's melded together. That's what makes this completely interesting, is that you have to get all this together and make it work.
That's awesome.
to keep people safe.
Rudy, that's an interesting point. There's so much that goes into developing one of these structures, mechanical, all the way down to how do we orient that building on the site?
That's right.
If we turn it 90 degrees this way, how does that impact the design and the cost of the project? And so you can really drill down when you're looking at these blast projects to sometimes the most minute little things can have a significant impact to a budget or to how the structure responds in a blast event.
That's right. Probably what we find as far as mistakes in the industrial world or these building design is that people who haven't actually talked to all the skill sets and made them actually work together to keep that envelope safe and the people safe inside. Half of that we've stumbled across other companies that have not designed the building wrong purposely, but just haven't gone beyond and made that all coordinated.
It's a lack of knowledge, a lack of experience.
Right. How that affects that building system.
Wow. Well, with that, let's just kind of jump into a round of questions. This one actually is for you, Rudy. First off, what is you and your team's role in supporting a client's blast program or a blast project? What do you and your team do on behalf of the client and with Structure Tone Southwest?
Well, I mean, that I could sit here and talk about 2 hours about that.
We have 2 hours.
I'm going to try to keep it at a high level. But what we try to do is help the client, most importantly, make the right decision on that building, whether it be damage level, like Aaron was stating, be cost effective, but at the same time keep those people safe, right? So the team, I would say at a high level, is we have to evaluate the site, evaluate the documents, and first and foremost, make sure they're providing, again, a safe building and how it was intended to react. So we're going to sit with the client, we're going to sit with the subs, we're going to sit with the engineers and make sure it all reacts like it should based on that design or blast event.
And just for the audience, when we say a building reacts, you're referring to an explosion of some kind, an event in a plant.
Right.
And based on the distance away from that center, the way the building's oriented, Aaron, to your point, there is an acceptable level of damage. Is that correct?
Right, and that's one of the pieces, and that's a good piece to talk about, because if I sit here and say I need my building to be per ASCE damage level 2A, 2B, some people utilize medium, high, and low, I have to coordinate that with Aaron, right? So there's already that initial coordination based on the information either I've gathered from the client or the directive I've gotten from the client, right? So I have to make sure he understands what I'm saying based on his scope, right? The skin, the envelope.
Well, what about now, from a project standpoint, the P&L of a project? Do we help clients in that regard of actually defining the scope, defining the budgets? What do we do in those realms?
Well, you do, because the worst thing you can do is just basically listen to the client and say, this is what I want, right? The way I've always approached any of my projects is that the client's hiring you as the expert, right? That's why he's bringing you in. So you do have to guide him. You have to understand what he's asking. In some cases, you have to push back and say, no, that's not the way we're going to do it. Or even Aaron will push back and say, we can't do that, and this is why. So a lot of it, a big piece is understanding that scope and then making sure it's developed properly from all the building systems.
So you're doing things like upfront consulting work, even
Yes.
before perhaps construction might get involved. You're probably becoming a trusted advisor at some level to these clients.
Oh, yes, we have to. Just because, again, we're talking to experts like Aaron all day long. We're talking to experts, the engineers who are doing the steel. We're talking to the experts with the HVAC. Is it shelter in place, safe haven? How does that react with his envelope? So we're constantly talking to the experts and have to make sure that gets back to the client and documented properly.
So in answering that, you referred a lot to Aaron. So let me ask Aaron and Chris to that same question. And you two are part of our support efforts for these clients. Where do you all fit into the supporting of this kind of pre-project stage around blast buildings?
Well, I wish we were more involved. We partner with Baker Risk as kind of our subcontractor, if you will, for the blast design. And seems like, and I feel like the industry is maybe getting a little bit better as everyone gets more educated, but it seems like we get into positions fairly often where we're brought in too late and the project has gone so far down the road already from an architectural standpoint or a siting standpoint with the building on site, or even mechanical. Where we're probably the most valuable is when we're brought in early to help consult and help guide the architect in a lot of cases on how to lay the building out, how to make it cost effective, how to mitigate the exposure to a blast event. Again, so the earlier we can get involved, the better position we can help with the client in. Oftentimes we'll get a set of architectural drawings that are completely done, and they may have 30-foot bays or 38-foot bays, frame spacings between my rigid frames. And in a blast event, that's not ideal. We can typically achieve, that spacing if the client really, really requires it. But most of the time we can cut costs significantly by shortening those frames and just laying things out a little bit differently. And so that's just a kind of a quick example of one little thing where if we were involved early, we could kind of steer the project in a more cost-effective direction.
That's a really good example. Chris, want to add anything there?
Yeah, sure. So one of the things that in my role at Structure Tone as the corporate office can really provide is making sure we have the relationships in place for one, because as we said, these are really complex buildings and they require teams to work together. I'll give you an example. Rudy and I talk about this all the time. It takes structural engineers that really understand that a building's got to be flexible and not stiff. Right. And you have to have that guy on your team to make this all work. Him and many of the other consultants. I just chose him as one example. But and also, these assets are not always where we have offices. They're on the Gulf Coast. They're sometimes remote locations. So it takes coordinating with all of our corporate resources to deliver projects there through all of our offices and our affiliates. So.
Yeah, and that's something we'll touch on later in the podcast. But
hey, Justin, let me add something
that
Aaron spoke about, and I think it's really important when he said, we plead to let us in early, let's get in front of it. And probably everybody's wondering, wait, if he has an architectural background, what's he doing in construction? Well, I always looked at all these projects. How can I help the client? How can this be a successful project? And being in the architectural world where I've designed these buildings from the ground up, then helping construction, then going into a design build aspect in my career, I think if we can get up front early, and I think if I'm in construction, one, I can help the contractor understand the means and methods of a blast building, which is very different. but also hopefully get in there early enough to help the architect or the engineer of record say, look, we need to coordinate a certain building system, finish, design, lighting based on the blast, or it's not going to work. So I'm hoping that, like Aaron was saying, if we can get in there early, I think our value for the client becomes immense.
Yeah, it's funny you talk about getting early. This will be a follow-on podcast later in the STO Building Group future, but Chris and I are working on this flipping the real estate process in which we get in very early and help clients make smart decisions outside of the blast realm. Well, let's keep moving on with our questions, and actually this one is for Aaron with Rigid Building Group. And Aaron, you guys are the premier vendor, builder, supplier for pre-engineered metal buildings, and I'm curious if you can kind of enlighten us on what are some of the unique characteristics of Rigid's product that makes it such a desirable solution in the blast world.
I tell everyone, Justin, when I'm asked to kind of describe Rigid, I tell everyone we're kind of a boutique fabricator, if you will. And by that, I mean we can run with the big guys. We can fabricate just about anything you can put in front of us. We have those capabilities and technologies in-house, but we're still a small enough company where we can be responsive for the client, which is kind of a spin-off of our business model. We started business as an engineering consulting firm 30 plus years ago, and we've grown into this fabrication firm, and we're very, very entrenched in kind of the engineering principles. And the company was founded on these engineering principles that if we can find a better way to out-engineer or design or outthink our competition, then that puts us in the driver's seat. And that's why even today we find ourselves in situations and partnerships with companies like Baker Risk, very unique niche type projects and service areas for our industry. So I think our ability to react and flexibility, being the right size company with a lot of fabrication capacity and technology, engineering support behind us, really is what drives Rigid's expertise today.
Then going on that a little bit deeper, what are some unique aspects of a pre-engineered metal building over, say, a cast-in-place concrete or a tilt wall? Because those could be solutions too, right?
And they are. In certain scenarios, that is the preferred method of construction. Pre-engineered fits a real kind of boxy area, if you will, and that's typically around 5 psi, pounds per square inch of side-on pressure or overpressure. Anything beyond that, you really should start considering concrete, whether it's tilt wall or cast in place. But some of the real advantages of pre-engineered steel construction, if you're in that box of 5 psi or under, one is cost. I guess that's probably first and foremost on every client's list is, what's it cost? And relative to other forms of construction like concrete or even modular, Connex boxes, modular blast units, our cost when we're under that 5 psi oftentimes is half the cost.
Wow.
And not just materials, but even construction costs. So it gets very significant, the delta between concrete and even modular units in that 5 psi window. Beyond that, and I'm sure you all have some experience here, is a lot of times or oftentimes a process unit grows on a facility or on a site, and all of a sudden you find the building that was erected 10 years ago in a 1 psi blast zone. As that process unit grows and expands and the plant expands, suddenly it's in a 3 psi zone. And to take a concrete building or a tilt wall building that's in place and harden it to meet the new 3 psi is oftentimes more difficult than future upgrades with steel. It's pretty convenient to take a metal building and add some additional girts or harden an existing pre-engineered structure. So it's got some, aside from the cost value up front, it's got some value long-term in as far as its flexibility on site to be hardened at a later date if needed.
That's all. And you hit a key word that I wanted Rudy and you and even Chris to kind of bounce back and forth, because we here at Structure Tone Southwest in Houston are seeing a number of these types of projects in our pipeline. We said hardening. What is hardening for our audience?
Let's answer that, but I also want to tack on something that Aaron said about 1 to 4 psi buildings, and that's where his box is at. But Aaron and I have talked about other projects where I've had let's say, masonry building or cast-in-place building that a unit has expanded and it's affecting one elevation of that cast building. Aaron and I have come up with ideas of providing a envelope that his envelope becomes more ductile. It takes on all the damage, allows it to flex, and then minimize any of the damage that wall is receiving now. So now instead of hardening that cast in place masonry wall, you allow that metal structure to take all the damage. So that kind of leads me into the hardening piece, right? So we've done projects where an existing building has been cocooned with a pre-engineered envelope and probably separated 6 inches, a foot or so away from the original envelope. Again, that exterior envelope is allowed to move, and it minimizes the damage to that existing building, right? So it has gone beyond just being, a simple pre-engineered building.
So to illustrate, if I'm understanding correctly, we have a concrete box, which is a control room, which has people inside.
Right.
And it now needs to be hardened. So you're essentially putting a pre-engineered metal skin with a 6 inch to 1 foot buffer around said concrete box. Is that fair?
Yeah, we're building a metal building over the top
Okay.
of that existing structure.
Right.
So it's roof walls, the whole deal. We essentially cocoon that existing structure that no longer meets the blast requirements, cocooning it inside this pre-engineered, this new structure that protects it from any damage in an event.
Or partial cocooning or partial hardening, right?
That's right. I was going to touch on that. Your question about hardening. If you have, let's use for example, you have a structure and you have one wall that suddenly, the building's 20 years old, process unit grows, and suddenly you find one wall that doesn't meet the blast criteria any longer. There are solutions that we can come up with to go in and add support and framing members behind that one wall to essentially harden that existing wall of, now to meet the new blast criteria.
Oh.
So there's a couple ways hardening kind of comes together.
We actually did a building where the roof was the one basically failing. So when the roof would fail and push in, it'd pull in the walls. The walls weren't failing, but since the roof was attached to the walls, it's actually pulling them in. So what we ended up doing, we put a false pre-engineered roof on top that took all the damage, and now you didn't have to harden the walls.
Well, so and that's fascinating, but I'm putting myself in the owner's shoes. It sounds expensive. So at what point do you say that doesn't make sense to harden it? What else do you do? Do you move it? Do you abandon it and you build a new one? What do you do if it's not cost effective to harden it?
Well, at that point, that's where we come in. Again, going back to what Aaron was saying, we got to come in early. We're doing an evaluation of the building. The fact that we're a contractor, we can go into our database, give you a good estimate, or we'll go out and hard bid it, and we will recommend whether you're going to do a new building or harden it, based on the study, working with all the experts. So I guess that's what really would be one of our expertise. We're gonna tell you, we're gonna recommend this is the way you go to be, first, cost effective, and two, keep your people safe.
Well, that's great. All right. This next question is for Mr. Talley, good friend Chris here. So, Chris, many of our clients have assets spread across the U.S. and Canada. All right. How is Structure Tone or STO Building Group uniquely positioned to support these clients and their multiple assets?
That's a great question. Thanks. First, let's start off by saying that we're uniquely qualified because of our expertise. We've assembled what I think is probably arguably the world's best blast team between guys like Rudy and Aaron and our other consultants that are all in this area that have grown up doing these kinds of buildings. This expertise is really unique. It doesn't exist a lot of places. The group of people that really understand these kinds of projects and that can develop them and lead owners' teams through them is really small. And I think we have the experts in-house to really lead our clients to success on these kinds of projects. That's one. We have a really unique skill in that. And second is, we have 3,500 employees spread across offices across the U.S., Canada, UK, and Ireland. And on top of that, we have alliance partners and all of the other places that we don't service around the globe. So whoever the client is and wherever they are, we can help them solve solve their blast issues in buildings across the planet. So.
That's awesome. So, we have a Houston-based client, let's say, for instance, and we're actually looking at a project in North Dakota. How do we manage that? A lot of home office stuff? Do we export expertise to North Dakota? How do we manage things that are really remote?
All of the above, right? So we definitely want our team with our experience on the ground, our boots on the ground there, and we draw resources from our other offices and our alliance partners. We have, in that particular case, we have alliance partners from Minneapolis to do business in the Dakotas. We also have one of our sister companies, Layton, on the West Coast, that does some work in the Dakotas as well. So we draw on their expertise and their relationship with local subcontractors to figure out the most economical and the right team to deliver that project.
And then, so with our partner Rigid, Aaron, you guys are based here in Houston, but you manufacture locally, deliver globally. Is that fair?
Yeah, we so home base is here in Houston for most of our domestic production. We have a joint venture in China that was started in 2011, where we do heavy steel fabrication, high rises, bridges. The feather in our cap right now is the new LA Rams football stadium. Was a steel project that we delivered. So that's kind of domestically, that's one of the big ones that stands out. But for us, we've worked over the years through a network of dealers as we grew as a company. So we had strategic dealer alliances, if you will, throughout the 50 states. And North Dakota in particular was one of my territories. I've got tons of people up there, literally, and this isn't a figuratively, hundreds of buildings in North Dakota. I've spent weeks up there in the man camps when the oil boom was going on, and have a lot of great connections. So we'll fabricate and ship just about anywhere.
Oh wow! Yeah. And so Rudy, as our resident blast expert, have you secured your private jet? Because with all the work coming around, it sounds like you'll be out and about the lower 48 at least for some considerable time. No, but from your perspective, you kind of oversee the technical aspect of this. How do you manage executing work from LA to Bismarck to New Jersey back to Houston?
Well, I think Chris really hit the nail on the head when he said we have all these partners and expertise and sister companies, which is great. Having that support really helps us. We can go to Chris and say, I have a project over here, how are we going to execute it? Great, we have this company, we have this sister company. The other piece would be, like Chris was stating, we have our expertise, like Rigid, Bakeris. We talk to many experts. So we've vetted them, we've worked with them. So we can reach out to any of our experts and tell them, hey, we have a project here. And they can either say they're going to do it, or they can even give it, hey, you can go to this other company that we trust. The idea that Chris was heading to was that we're building trust with all these other companies, and I think that's how we execute. We got to trust each other. We got to build those relationships. The fact that it's such a small niche type of blast type of approach, we can reach out to our experts, right? That's what really helps us. We got to continue to build those relationships, right?
That's awesome, and that's what we're talking about here, guys. Is something that our corporate leadership has been touting, I think, since they started the business, to be trusted advisors, to establish 80% of our business is repeat business, and it sounds like this sector is definitely going to fit in that mold. But let's go on and move on to my last formal question. This is for everyone. It's kind of a fun one, so I want everyone to chime in and have fun with it. But there are a lot of buzzwords in today's energy markets around renewables and clean energy. What do y'all foresee the future of blast solutions in a renewable or clean environment?
Well, it's nice to see where it's going, right? Any type of new approach, new energy, clean energy, sustainable, I think those are all great words because, that's going to motivate people to look at something in a different manner, right? We may not be there, but we're going to get there, right? And I guess that's really the approach. If you don't present anything new and challenging, then you're not going to look at it. You're going to follow the same route. And I think there is a place for it, and I think it's going to be developed. But again, it has to be talked about. It has to be investigated. It has to be studied, and see what that value brings and how it's brought. Is there a hybrid? Sure. And eventually, as the technology moves forward, I think it's going to get there, and I think that's where we're headed. got to be around it.
Yeah. Chris, anything?
Yeah, I was just thinking way out of the box, right? So think about a blast building, right? So a blast wave is like a punch from a boxer. Rudy told me one time. That really illustrated to me what the difference would be versus a building that was built to withstand a wind event, right? It's really different. So think about mass timber, CLT, and how the shape of that building might take that impact from that blast better than a traditional building. Using mass timber and CLT, we can shape that building, and it's got ductile properties on its own. And so I think some clients have already asked us about that, and we're considering it. And I think that may be kind of out there in the future, but something we may be considering.
Now, are you guys talking about copyright and the whole idea of blast sustainable mass timber? Is that what I'm hearing?
As far as we know, we may be the first ones. Yeah.
Well, Aaron, what do you have to say about the future of blast in this renewable, clean world that we're in?
It's hard to say because we're not there. And I think for me to really, or for anyone to really get a clear picture of what the future holds when it comes to renewables, while the idea is wonderful, I think until we get there and we get the really smart folks to get the science kind of behind what's going on in these in this new renewable world, if you will, it's going to be a little bit of wait and see kind of how things develop and where this goes. Because while the idea is sounds wonderful, I don't know. I mean, there's certainly a big push to get us there in a short period of time. But the reality is, it may not happen for a while. And I think just like any new technologies, you kind of have to get there and kind of work through some of the kinks and feel them out. Yeah, stub your toe a couple times, and you learn, you grow from there. So for me, it's kind of a big question mark still.
Right. And what's interesting is that blast years ago has evolved differently than it is now. It used to be, let's make it as hard and stiff as we can, make the walls thicker and thicker. Right now we're talking, hey, let's make it really ductile. So blast has evolved through all these years, and I've seen it. It's really been interesting. So bringing in renewable energy and problem solving for their ideas is going to be a process, and I think it's really exciting to see what's going to happen. But we have to be presented with those issues, and then we have to figure out how to resolve them.
It's interesting. Our teams here, to give credit where credit's due, Michael Neary Jr. in our office has been working with this local clean technology group where they make clean hydrogen, but they do it so by this little, basically, if you think of a container, shipping container size unit, well, that thing can go boom.
Yeah. Right.
And so now what they're talking about is building a box around the boom center, which is, I guess, in a way almost like a reverse blast building, and that you guys go boom and you need to contain it and have a way to direct the actual force. Right. So who knows, maybe with renewables we flip the blast process.
We've seen some of that in some of these facilities now, some of these labs and other type facilities where you have an internal blast pressure and you also have an external blast pressure from other sources outside of that particular building. So we've been involved in some projects where we've had to use vented panels on the wall to release that pressure out in the case of an internal blast, while designing the structure at the same time to meet these external blast waves from potential alternative ignition sources. So it gets pretty interesting. Some
and what you're bringing up that's really interesting is the venting, right? Mm-hmm. We've been doing that for a long time now, right? So this new idea about let's put a box around it, and now we have to reverse the blast, it's actually already been there.
Yeah.
So you're going to be implementing these
similar
technology to the new technology, which goes back to there's that hybrid that we're going to bring to the table, right? But we have to be presented with that idea.
I still like the mass timber blast buildings myself. But, all right, well,
Richard may not like that.
Let's just stick to steel.
Well, hey, I just want to say on behalf of the STO Building Group, our amazing PR team and marketing team, thank you all for being with us here today, sharing your enlightenment, having a few good laughs, and getting the word out about blast.
Yep.
Thank you all.
Fantastic.
Thanks so much.
Thank you all. Thanks for having us.
Yeah. Thank you.
Thanks for listening to Building Conversations. For more episodes like this, you can find our podcast on Spotify, Apple Podcasts, Google Podcasts, or the Structure Tone website.